Hello all, we are here for the lesson number 23 of this VariCAD training course, and this lesson is called Mechanical Part Calculations. This is the second and last lesson of this section 4. Okay, so with any further delay, let us see what we have to see in this lesson. So we need to go to this objects menu and to this command calculations, and what we will do and see are the commands inside this option. So basically this lesson will show you how to use the calculations that are inside the program. These are not complex calculations, but I think they are very cool helps for several situations of the mechanical engineering calculation process. So as you can see inside the calculations, you have several options. We are not going to see them all because basically these are definitions and knowledge which any mechanical engineer has to have, and we need to see the concept. We will see 2 or 3 of these calculations, and all the rest I will leave for you. If you want to go a little deeper, you should consult some documents, books, or whatever you have regarding the specific calculation you want to see. Okay, so we have all these calculations: compression springs, tension springs, square keys, spline shafts, bolted connections, round pins, bearings, V-belt drives, roller chains, purge gears, straight bevel gears, shafts, and beams. Besides all these options, we have a little different command, but I'm considering that this will be a calculation because the results can be used for some of these calculations above. So we will start and see first this to the area command. For that I will draw, I'm not especially worried about the shape, I will draw a strange shape, for example something like this. And again, as I've done in other cases, I will explode this. So now I have a closed shape, a very strange one. It could have other elements, but to be easy, I'm doing this one. So now I want to use this last command, which is the to the area. And basically I just need to click inside the closed area. I could choose the elements, but I will click inside and it will found me the boundary, as you can see. Now enter or click on the right side of the mouse, and okay, first you can see the figure that is highlighted, so the boundary was recognized. And regarding the 2D area that is inside this boundary, we have a lot of information: section area in several units, the length of the outline, moment of inertia with the axis, bending section model, and the center of gravity of in both coordinates. And I can create the lines on the center of gravity just doing this. Okay, and that's it. The center of gravity is on the intersection. So this is very easy to use, and I think a very nice function and useful function. Now regarding the calculations, okay, we've seen that we have all these options. We will see 2 or 3 here. For example, one I think very useful, besides all of them are good, but I like this one, for example, bolted connections. And to give you a quick example how you can work with this, this is not an extra powerful module in any of the calculations. Basically, these are dialog boxes with some options to check conditions of specific calculations. In this particular case, for example, we can check if a given bolted connection it is okay or not okay on the conditions we define. So, for example, if we give an external force in newtons, for example, let us see 5,000 newtons, which is more or less 500 kilos, an allowable stress in these units, for example, of 400 MPAs, and I will check for this bolt M1 with this thread if the condition is sufficient or not. I can have this condition here below without preload or with preload. Just a quick explanation. The preload is something that when we have a bolt with some nuts and some washers, and we screw them with a certain force, this clamping force is called pretension or preload or whatever. So I can have this condition here. To be easier, I will say without preload. Okay. So for these conditions, I will do the check, and the check says that screw is not sufficient, or saying on a different way that for these 500 kilos with this allowable stress, and this is something that is regarding a property class for the bolt, and in this case is for a property class 4.6 in lower medium carbon steel. You can have other type of bolts, but I'm considering this one. And if you look a little in specialized book or documents, you can find all this explanation about the classes and the units for the allowable stress and the values. In this particular case, it is not sufficient, but I can do something like this. I'm doing an example and trying to show what is good or what is not good. So M1 is not okay. I will try a M3 and do the check again, and still not sufficient. Putting a little bigger, M4, not yet. M5, now it is sufficient. So you can work with a program in something like this, to execute the condition for several screw dimensions until you get one which is enough. In this case, probably the M5 was very close to the limit. Maybe you could come here for M8 or M10 and put a bigger screw. Okay, but this is the way to work with this, and you have the possibility to have different threads from this list to try and to check. For example, a different calculation like bearings calculation, it is quite interesting also, because you can use the SKF catalog, and it is quite easy to work with. So you can choose from the type of load, constant, impact, linear, or out of balance, the installation type, and the calculation, design, or control only. So I will use the basic one, constant, tandem, and design. Okay. Now I must give the conditions for the forces. So let us use the same values, 5,000 newtons, or again 500 kilos. Actual force I can do, for example, 2,000, and I can say that this will work under 10,000 RPMs, and I want, for example, 50,000 rating hour life. So I can give some coefficients, and you can see that this is a sliding bar for the reliability. It's a very difficult word for me to say. And the safety factor. Okay, I can use much bigger factor or lower factor. So do the okay. I can have this condition filter for the for the tolerances on the shafts, on the bearings, whatever. I will not use these ones. And I can say, do the design, give me the references that are okay for this condition. So I have all these conditions with the diameters and so on. I can choose one of these. I can get the info of this guy here, okay? Single row ball with all these things, with all the results, whatever. I should check on the place and under the conditions I want to install it, if what it was good. And after I choose a good one, I can say draw. And then the draw, I have the conditions, complete sections, only the sections to shaft, whatever, the hatching, detail, schematic, whatever I need. So insert, and here is my bearing, okay? It's a good checking, very easy way to verify your calculations. One more, I have all these kinds. I think a very good one is the shafts and beams, okay? Very easy. Let us try to make some quick example. So, for example, we will define all these things around here, and we will start by the beam properties. So, total length of the beam, for example, 5 meters. Elasticity modulus, this value. Poisson ratio, allowable stress, I will use the same one that I use for the screw. Number of beam elements, I will not say as much, I can say 10 or a little more, 20, and that's it. And the method for doing the calculation. Now, okay, so the beam is drawn here. Now I can have a beam or these with different sections. I can say which is the type of the section I'm working with, and I can give different things for different parts. I will make it very easy now. I will use, for example, a circle one, or a tube if you want. For example, 30 millimeters diameter, thickness 3 millimeters, and the length of the section will be the 5 meters to be easier to do. So now the supports, I can give to the program supports. I can give, for example, location, a movable one, location, for example, at 1 meter. Okay, here it is drawn. I can add have another one, for example, at 3 meters, immovable one. Okay, here it is again. That's it, no need to put anything else. Beam loads, I can define loads also. For example, let us put, I like a lot of this 5,000. I can give, for example, a 30-degree angle, and I can say, for example, 1.5 meter. Okay, that's it. Now I can give, for example, distributed load, for example, 1,000 newtons meter. Linear, I can say 2,000. For example, I can give here from the 3 meter and initial point, I can say, for example, 2 meter, and say the OK. I can add, for example, a torsion moment, Newton meter, I can say 1,500, and the location I can give, for example, at the 4 meter. Okay, I can do a lot of things here and do the OK. And at this point I can say calculate. Okay, no problem. So I need to change this, what it was here, statically in turning around axis. So I can give, for example, the loads. Let me take this out and try to calculate it again. So now, as you can see, the calculation was done, and we can see display results, okay, reactions, strains, okay, in all these things here, internal effects in all the elements, okay, stresses down here, and we can see the graphics like this, okay, for all these options, slopes, bending moments, bending stresses, whatever, and torsion if I add torsion moments. After all this, we can also save results in HTML to open on a web browser. So basically, these are the options. These are the options to work with the calculations inside VariCAD. So with this lesson, we will finish this section number 4 of the training course, and I hope to see you on the next lesson and on the next section.